Hello, everyone, and thank you for joining today's session on Codelaborate at the Reactor Code Lab. My name is Irina, and I'm the event planner for the Redmond Reactor space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and our presenter. Engagement is encouraged in the chat. This session is recorded and will be available in 24 to 48 hours on the Microsoft Reactor YouTube channel. Useful links will be will be shared in the chat, which brings us to today's session. This session is approximately 1 hour with questions for throughout. Our speaker today is Sam, who is a regional cloud advocate. Hi, Sam.
Hello. Hi, everyone. I'm good. I am Sam Wronski. I am a regional cloud advocate here at Microsoft. I work for the San Francisco region, trying to help empower people to build really cool things with Microsoft technology. Today, we're going to be kind of taking a look at an intro to Docker, but we're going to be taking it in a bit of a different path. One of the things we're trying with this Reactor Code Lab is a way for us to kind of explore new things and kind of show my process of learning new things and kind of walk through what that looks like. In this case, this is something that I'm actually fairly familiar with. But we're going to be kind of throwing a few different curveballs at it to make things a little bit weird and hopefully share some fun things. And what I think is one of the funner ways to learn DevOps and observability and some of the other cloud stuff that you can do with containers. So that's what we're going to be doing. So I have a Getting Started with Docker tutorial pulled up. There's a link in both the chats here. And so that's going to actually allow you to kind of follow through a little bit. But we're taking this in a different direction. We're going to be running a Minecraft server with this. So typically, I've done these sessions in the past where we've walked through setting up Docker and how to do all of that. One of the things is if you're just setting up a toy app, something that you're just testing with, it can be hard to understand how things are working. The cool thing with running like a game server for Minecraft or Factorio or any of these other servers that do have Docker support, that becomes an interesting thing. So we're going to pull in a few community things, including a container that is built by the community to kind of help us run Minecraft servers inside of a container. And then we're going to experiment with how we can learn Docker through running a Minecraft server and how all of that works. And hopefully kind of give you some leads that you can use to learn all sorts of other fun things. So this leaves a whole bunch of open questions. There's a bunch of different choices we can make here, and I don't know the best ones. And I've kind of left it open. We can kind of choose what we want to do here. So if people have suggestions for, say, a server type that they want to host, or settings for the server, definitely call those out because that would be really cool, and we can experiment. But for the most part, we're just going to walk through this, and we're going to swap up a few things to kind of do it for Minecraft, and hopefully kind of use that as a way to introduce you to some of the cooler parts about containers and why they're so useful. So here we go. So the first thing we're going to do is just run a container. So in this case, we're running a container with dockerrun. I'm going to zoom in just a little bit more so this is easier to see. But dockerrun is how you run containers. It's the way you execute into something. Containers are a lot of times compared to virtual machines, but that's not really how that works. They provide an abstraction layer between the host system and what is currently running, and sort of an isolation layer between them. But they don't virtualize everything. So you don't have a virtual network, and you don't have virtual hard drives, and you don't have all of that. They reuse the kernel, for example, of the OS that you're hosting it on. So things like that can get reused, which makes Docker containers, or just containers in general, much smaller. I'm going to be talking about Docker containers because I'm on a Windows machine. I'm using Docker Desktop. But there's other alternatives to that too. If you want to use Podman or Containerd as different options, Podman gives you the full container runtime. I'm mixing up the words here. But container runtime and Containerd does the same thing. So you can use those. Those are targeting more on the Linux environment. So either way, one thing you will run into when you're running things on Windows is there is an option to choose between Windows and Linux containers. So in this case, I have it set to Linux containers already. That's what we want. Windows containers will give you a Windows-based environment, which is a very different experience than a lot of other containers might be. They are not cross-compatible in almost all circumstances. So you can't just take a Linux container and run it inside of a Windows container environment. That typically isn't the use case you're going to be looking at. So that's what is going on here. So dockerrun is actually what's going to run this thing. It's how we're actually going to say, take this container with this image and run it and do something with it. -D is going to run it in detached mode, so it's not going to hold on to your terminal. That means you're not going to see any logs. You're also not going to see anything else. It's just going to start it and then disappear. The next thing is -P, which is actually going to expose the ports. So that's actually going to determine what ports are displayed. Because containers isolate things from one another, if you are not exposing a port, in this case, we have :80:80. What does that mean? In this case, we're saying take port 80 from our host machine, which is the machine we're running the container on, and map that to port 80 of the container. They're two different things. And that means that you can have, for example, if you're hosting multiple websites on port 80 or port whatever, you can map them to different ports on your host machine so they don't conflict. So you can run multiple different services that might internally use the same port number without conflicting them and causing a bunch of issues. So yeah, that's what's going on there. And then the next thing is the tag. That's actually what image we're referring to. So in this case, it's docker/getting started. So let's just, as a real quick thing, let's just run this and see what happens. So let's get rid of all that junk. And also, let's not run it in an elevated prompt. That's probably not a good idea. There we go. Bunch of work. So if we just want to run this, we're going to get a warning. That's not the right link. There we go. Copy it and just run it. So in this case, Docker getting started. We're just going to run this once. This is just going to be the only time we're going to use the default stuff. And so this lets us run this. What you're going to see is a whole bunch of fun stuff. I'm running through all of this just so you have a basic understanding of how containers work. Because if you, there's a few gotchas that you might get into trouble with if you aren't quite familiar with them. They might catch you off guard and cause some issues downstream. So we're going to cover that and sort of why Minecraft containers actually mean that you get to learn some of that stuff. Because you're dealing with it, you're building a world in it, right? And so you actually want to experiment with that. So that's what we're going to be doing. So we saw a whole bunch of stuff happen. Each of these lines here is a layer that is pulled down for our container. Layers are different configuration levels for the environment that we're working on. There's a base layer of whatever it is. Maybe it's Ubuntu or something else. And then each one above that is actually pulling in different things. So running different commands, pulling in new packages, configuring specific environment variables, things like that. So depending on the image you pull down, you're going to see different things. You can also see the image we pulled is not the one that we said we were going to pull. There's a little bit different there. So in this case, it says unable to find image locally because I did not have it on my local machine. So Docker automatically pulled it for me. But it also tacked on this :latest to it. That's the default label. And what that's going to do is say, grab the latest version of this. So this lets you pin to specific versions of an image. For example, if we're talking about .NET, you might want to point at .NET 5 or .NET 6 or any other one. But pointing to just the newest one means that you break every time a new one is released. So this can be a way to, by manually tagging that, you can avoid some of those issues. So now we've downloaded our image, and you can see this SHA down here. Looks gross, and I'm not going to remember it, so we're just going to take the first 4 characters. And just docker ps. We have this thing running, so docker logs. You'll see that Docker already shortened this container ID down from that really long SHA down to this. So it's getting smaller and smaller. We can make that even shorter, or we should be able to, with just taking the first 4. And there we go. There's some of our logs. Let's send a quick thing over there. And we get something. Oh, this is a full web page. All right, we can just do this. There we go. Getting started. So that's our container. That's what's running this whole thing. Now, let's skip all of that and run something else. So what if we want to swap out this? But also, we want to run something that is not on port 80. Minecraft servers by default are on port 556. I have this written down. 565. There we go. Numbers are hard. So we're going to swap those out and then run this. So I'm going to be using this itcg Docker Minecraft server. So this is a community-built Docker image with a whole bunch of documentation on it. It's out on GitHub, so you can just go and browse all of this. And also, feel free to suggest things from this that we should check out. I've been running servers with this for about 2 years now, and have explored a decent amount of it, but not all of it. So there's certain things that I just do not know yet. That's sort of why we're here, is to learn some of this. So if something in here looks interesting, let me know, and I will be happy to dive into it. We want to run this image. So let's grab that. You can see this sample for the latest stable run looks very similar to what we were just doing. There's a few extra things. There's this -it. We can drop that, and this is changing the port number. And we also have something to accept the end user license agreement. This is a flag that just says accept this, because you need to accept that in order to run the Minecraft server. You didn't know, Minecraft servers, you can go and download them if you want to run your own Minecraft server. This is where you would get the Minecraft server for whatever version you want. This is the download page for 118.1. But this image actually goes and downloads that for you. So you can actually just rerun that. So let's start swapping some of these pieces in. So if I go in here and do, that's not right, docker ps. So docker ps is going to list all of the Docker images that I have, or containers that I have running currently. A container is the current instance. Images are the templates. I like to think of them as blueprints. They're the thing that says, here's what this should look like. And then it lets you recreate them. And that's sort of the cool thing, right? If we're trying to host a Minecraft server and our friends are using it, we probably don't want to be experimenting with new mods or new settings or new things in the production version. We don't want to be shipping all of this stuff and breaking our world when we don't even know if it's going to work yet. And so the cool thing with Docker and containers and what they allow you to do is they actually allow you to swap that out. So you can actually pull things out and say, this is what the world should look like, but I'm going to run it over here instead. And then if it breaks, it only breaks on my machine. It doesn't break everybody else. So makes it really fun for kind of iterating in that way. So let's swap some of this stuff in. First thing, we're going to stop this current image. So docker stop. I'm using different ways to do this. You've noticed I've used the SHA previously. So we had 4021 just as the initial bit of the SHA. And then I just used the name. They work the same way. They're aliases for one another. So you can use one instead of the other, whichever one makes sense to you. You probably are going to want to actually give things names and use that name, because the SHA is going to change every time you recreate the container. But either one works. So you can refer to them in either way. And then using the shortened version means you just don't have to type the whole thing, because that's just a lot of work. So anyway, let's run this thing. So docker run -d. We can actually just go back up to our old command, -d. Do 25565, 25565, and we need to do -e. What -e means is add an environment variable in Docker. So we're setting an environment variable that says end user license agreement equals true. So this is going to actually allow our server to boot. Otherwise, you'd get an error that you needed to accept this. And then we just need to point to the correct Docker image that we want. What this is going to do is actually run this thing and actually get us a server, and we can actually connect to this. This is all you need to get the server running. And so you didn't need any fancy things. It just did its thing. This does take a little bit of time. So if we do docker logs -f just means follow, and then I can just paste that in, and we're just gonna follow along. You can see it's unpacking things. Looks like it's starting, but normal server stuff. Yeah, that's like how to start a vanilla server. There's a whole bunch of reasons why you probably don't want to actually do this. That makes this really, really complicated, but this is probably the best place to start, because you can see how all of this works. Once this finishes with the spawn area, we should get a loading thing. I should also mention I've been having weird issues with my Docker volumes, which is important to call it because we're going to be using them a lot in this. So I don't know if it's an issue with my PC or something else, but I've been running into issues with Docker volumes that cause a whole bunch of errors to get thrown in my console. You won't see them here because we're not using volumes yet, but you might see them in the future. So that's what's going on there. I've been trying to figure out how to fix it, but I couldn't figure it out before this. So it's just going to be a thing. Everything's running. We have our thing going. So we can actually just jump over here, refresh this, and now our server shows up as Minecraft server, a vanilla Minecraft server powered by Docker, and we can just run it. And now you can see I'm actually connecting and am in the world running around inside of Docker. So that's how all of that works. And this gets you started. There's a whole bunch of problems with this though. The big one is typically you don't want your world to go away. When we talk about containers, one of the things that we really care about is that they're stateless. A lot of the times you want to build stateless things in containers because containers themselves are intended to be volatile. I think that's the word. I'm not entirely sure, but you should be able to cycle through them. And so the issue that we run into is that you want to be able to recreate these things without losing data. And you do that by making them stateless. We don't have that luxury because we have an entire game world that we're trying to save. So this is where volumes come in. This works well for your own servers where you have an actual stable thing and you're not so worried about like the actual computer itself failing. It gets a little bit more complicated if you were to try to scale this up. But again, this is sort of intended as a, hey, you can use this to learn Docker, and it's pretty fun. So anyway, there we go. We have that running, and I can even, press a bunch of buttons. If I hit Control-C, that will get us out of the log stuff. And so if I do docker logs, not logs, ps, there we go. So this is our currently running server. I'm currently signed in. I can stop this. So docker stop 11F8, and the server shuts down. And so that's how this actually all works. We're connected to the Docker server through that port. I didn't need to enter anything, and I had already configured this to look at localhost. So that was all set up for me just ahead of time. But this gets you a way to kind of iterate on this. And so now we can start walking through and doing a little bit more of this. So that's step one. We've run a container. So let's jump back here and actually start looking a little bit deeper into some of these things. So the other cool thing is there's a Visual Studio Code extension for a lot of different Docker things. So a lot of the stuff that I just did, you can actually find in here. If I go into my Docker, there we go. It's sitting in here somewhere. There we go. So this is the container that we just stopped. So this is our server. So I can actually get that back if I were to start it again. So I can actually go into Visual Studio Code and click start, and it should just start up for me. And so now we have that running. These ones up here we're going to get into in just a bit, but that's what's happening there. And so the server should be back up. Yep. If I go and nope, never mind. It might take a little bit of time. All right. Well, we're not going to wait for that. So let's jump back here, and then we can come back to that in a bit. But this is actually really cool because it allows you to see all these things. It also lets you browse volumes, which could be really useful. So I mentioned volumes could get lost. There is ways to recover volumes if you do something weird. So if you create what I just did and have everything stored into some weird ether place that doesn't really exist on your computer, you might be able to get them back through the use of volumes, but that's not something that I'm super familiar with. You can see this one is actually, this random string of numbers is actually assigned to that specific container that stores our world. Volumes are where that's actually held. That's what's actually storing all that data. That's where the world exists. And so that's the important bit. That's the part we really don't want to lose. But right now, the only way to access that is through the container. And so we want to probably not have that happen, because if you want to install mods or you want to change some configuration or you want to do something else, it can be a little bit clunky to do that over and over again, especially because anytime you change a configuration, your entire container is going to get recreated, which means your entire world is gone. So you can't just open up a new port on your container. That doesn't work. You need some way to be able to persist your data. So volumes are how you do that. The default is going to be something just hidden off in the ether, associated specifically with your container. But you can associate it and bind it to your specific file path. So, all right, next thing, let's go to our application. I think we can skip over this a little bit because this is just cloning things. We're doing Docker or we're doing Minecraft. So we need less of this. Update, share, persist the database. There we go. So let's dive into persisting our database and how that all works. So this talks a little bit about our container file system and what's actually going on. So this is actually looks like create a file name data.txt with random numbers. Oh, so okay. So this is actually just creating things and then looking at different things. Okay, got it. Okay, this is stuff that we were just talking about. So maybe we don't need to go too deep into that. And then container volumes. Containers start with each container starts with the image definitions each time it starts. So every time you restart a container, you get the same thing over and over, which also means every time I recreate my Minecraft server, we are going to get a different world. Because I restarted my existing one, it's all still there. We're still on the beach. But if I do this and stop this again, might take a little bit, and then we can restart a new one. We're going to end up in an entirely different place because we're going to get all new stuff. And the seeds are randomly generated for this. So it's all just going to be random. We can do all sorts of fun things. So I'm just going to do that just to see what happens. We are basically just leaving that. I am just stopping these containers. So technically I could go back, but that's the thing. So volumes. Let's talk about volumes. This starts by creating a volume. Okay, we can do that. Let's explore that. By creating a volume, we're creating a named reference to something. So that's what's going on here. By default, to-do app stores in a SQLite database. Rest to to-do.db. You're going to use a named volume. Think of a named volume as simply a bucket of data. I think that's probably a good reference for it. That's what they are. They're just going to store buckets of data. So volume is just a hard drive. I think that's a good description. It might not be a good description. But think of it as just a hard drive or something that you are physically storing devices on, but it's its own thing. It can be pulled out and moved and used in different places and referenced uniquely. It's not tied to any specific use case. It's not like welded together or something. So that's what's going on with volumes. So let's create one of those. So first off, did our world change? Where am I? I'm in the trees. All right. So it changes. Thing to note. So let's create a volume. And I admittedly use this very little. I use lots of binding things, which is the next step in this little tutorial that we're walking through. So in this case, we're going to do Docker volume 8 Minecraft world. Sure. We'll create a Minecraft world. So this is just a Minecraft world volume. There's nothing in it. It's not associated with anything. It should just exist. And so now I should probably stop my thing. Docker stop. Boring. That's going to stop that. And so now what we can do is mount a volume. So everything that is actually inside of this Docker image that we're using ends up in the data folder. So what we need to do is map from the left-hand side, which is on our host machine, referencing either a location on the host or a volume by name, to whatever is inside of the container, whatever location we want to map to in this case. So let's go back to our run. And in this case, we want to run -v, and we want to take our newly created volume, our Minecraft world. And we want to map that to something. So I don't know where we want to send this. So let's just look here. And we should hopefully be able to find that pretty quickly. It's the data folder, but I'm hoping to show how to find this. Let's the data directory. That's probably not a useful way to show how to find information, is just search for the answer you already know. In hindsight, maybe that wasn't the best way to do that. Oops. But if you send things to the data directory, it just works. So that's what we're going to do. Also for time, because I do want to touch on a little bit of the more advanced and fun things that you can get into with all of this. So let's do that. Let's map it to /data. So this is based off of the root directory of the container, not your host, not anything else, just the root directory of the container. Can show how to look into that and figure all that stuff out if people are interested. But otherwise, we might skip it. So what this is doing is now running this, but it should send that into this volume for us. Which accomplishes very little for us, I think. Let's double check this, because again, these I'm not familiar with. I don't use them very much, or like at all. Set the container, open the app, and then go remove the container, and then you should be able to do that. So that's like the main thing that's being demonstrated here, is that you can actually remove the container. So we will do that now. So we have this. Let's quickly refresh. There we go. And so if we jump into the server, it might take a little bit. It might be generating things still. But hopefully this all works. I also did mention my volumes are being a little bit weird. They've been throwing weird like chunk loading issues the past few days on this computer, and I don't know why. So that's a thing. There we go. All right. So we're joining the world. We're in another new place. Now we're on a grassy beach. So more fun places. So let's disconnect again. Let's completely remove this. So I want to just delete this image or delete this container, not the image. Docker stop. Let's stop that. And then we should be able to remove it right after this. Yeah, that's how you spell that. Cool. So RM actually gets rid of the thing. So when we've previously stopped them, you notice that I could just click start again on any of them, and it just restarted them. If you remove them, they're gone. So that's not possible anymore. That one's just wiped away. But because the volume is still there, we should still be able to reference that. And so we should still be on that grassy beach. Even though we deleted the container, even though we recreated one, the SHA has changed. Things are different. I look at the logs for this. I think we'll see something interesting. Yeah, we didn't create a new world. We just kind of got into it. Maybe we're creating a world. I might be going too fast. Some of this stuff does take a little bit of time. So it might take a little bit to just get started. But we should be able to just try to, nope, not yet. Not quite to that point. So after we do volumes, I have a question for anybody in the chat that might be watching. Is there a Minecraft host or server tool that you use? Like, do you use Spigot or Fabric or Bucket or something else? Because we can pick any of them, and we can kind of walk through that. And I can just show you how to run that. They're all fairly similar, but I'd be really curious if anybody had one that they wanted to test out. So I will leave that as an open question. All right. You've used Spigot. Okay, cool. So we can try Spigot as an example. I do have some plugins for that. So we might even be able to get to mods if we have another 30 minutes. We'll see. I don't know how far we'll get exactly, but if I reconnect to this now, hopefully we now have our grassy beach. So we're back in the same world as we left off. So everything seems to be good. We're getting our world back, I think. So that looks like it might have recreated the world. I'd need to double check. Okay. Yeah, interesting. It should just let you re-reference it. So that's what I believe happened. It's really possible that we could have just got enough seed that was very similar, and it did regenerate, and I screwed something up. But we're gonna move forward because yeah. So volumes. We've just been exploring volumes and how to like create named references to them. Now we're gonna look at binding them. So when you bind them to someplace, you're pointing them to someplace on your host and saying, put it here. And this allows you to actually mount and share information from your host machine with what is inside of the container. Typically, that isn't supposed to happen. You're typically not supposed to access the host machine. The point of a container is that it doesn't rely on the environment it's running in to do its thing. What is contained in the container should be sufficient to run whatever it is. In this case, we're saying that's not quite true. You need this. And pointing it to a specific volume that stores, in this case, our world. So we're going to give it a data folder that stores our world and can do all of that stuff. So syntax for that is just to do a path on the left-hand side instead of the name. That's the big difference there. So let's give that a shot. So I'm going to jump over here. So this is my test world. Well, we're not quite there. Let's not do that yet. Too much. I'm going too fast. So we have our Docker run. We're doing all that. But now we're going to change this Minecraft world to something else. Let's call this. I'm realizing before I do this, I should make sure I'm in the correct place. Yes. Okay. So I don't end up creating a whole bunch of stuff in places I don't intend to. So you can use relative paths here. They can get a little bit funky. So typically I would recommend using absolute paths. We're going to try a relative path though, because that's why we're here. Minecraft data is just going to be the name of the folder that we're going to try to store this in. It doesn't exist, but it should be in this Visual Studio Code that I have behind there. It should be the same place. So if I run this and it works, you should see a new directory pop up. Might not show up because I need to refresh. Also, that didn't work. Oops, port is already allocated. All right. I mentioned that you couldn't reuse ports. We didn't stop our previous container, so we're running into issues. We could just move the port. That would work. But that's probably not what we want to do. And typically this won't be an issue unless you're actually mapping the ports. If you skip this port mapping bit, you won't see your server and you won't be able to connect to it. So that's one of the first errors I've seen when people try to reproduce this, is they don't do the port mapping. So I'm going to call that out because I just oops. And so let's docker stop and let's get rid of that. And then we can try to rerun that and see what we get. And hopefully this time I didn't screw it up. So there we go. So it's actually running this time, and hopefully I'm going to see something pop up there. Or I'm in the wrong folder. Also a possibility. Or nothing. That's weird. Okay. Interesting. That wasn't what I expected. I think we want an absolute path. I might be confusing Docker Compose and jumping too far ahead again. So let's experiment with this, because I don't think that did what I thought it was going to do. I think it's referencing something else, and that's probably not great. So, oops. This should still work. It just might be a little bit weird, because I don't actually know where that ended up. We could check, like Docker volume lets you, just like we had in Visual Studio Code, you can use Docker volume to go in and inspect what's going on, or just run Docker volume and then Docker volume ls. We have a whole bunch here. I believe this one, the most recent, is going to be the one that is storing that, or it could be one of these. Nope, probably the other one. Anyway, that's what's going on there. So let's fix this. Yeah, so Docker Compose uses YAML. That's sort of the fancy bit. I believe that's at the end of this, as we get into Docker Compose in the next few steps. So I can actually, that's sort of where this really gets really interesting. So we're gonna let's try to get to that point, because I think that's sort of the thing. So let's do that. In this case, we're gonna do volumes. I'm gonna do that in Docker Compose. I think that's a nice medium. And we do only have 20 minutes, and I do want to touch on a few of the other fun things that you can do with all of that, and things that you can iterate on and kind of explore yourself to make this more fun. Yeah, that sounds like a actually really fun thing to do. So let's try that. I've had this Visual Studio Code thing sitting around here for a while, with a backup Docker Compose thing in case I screw this up. And then we're just going to do dockercompose.yaml. I think it's supposed to be .yml. I don't know if this matters anymore, but I feel like I remember it used to. YAML should work with either file type, but there's certain times when it hasn't in the past. Certain tools have been very particular about what like YAML file names they accept. So we're going to do that. Also, this Docker or this GitHub repo has a Docker compose file that you can just start from. So let's grab one of those using Docker compose. We can just grab this and let's talk through what this is doing, because this is really where all of this gets into the interesting bits. I talked a little bit about how this is a really fun way to get into like the DevOpsy and the more observability side of engineering. And this is sort of, in my view, where it starts kind of coming in. This is where you start sort of moving from scripting and creating these one-time things to just set up this server to let's define what it means to run our server. That's what this file is. This is the definition of what your server is. How does it run? What resources does it use? Where does it run? What does it need? All of that goes in here. And so this gives you a way to define all of that. And it just means that you can run this anywhere. And it should just spin up and give you your thing. So that's the cool part that you're going to get out of this. You're going to get a way to access your server and be able to actually iterate over it. So if we look at what we were running previously, we actually have a lot of the same things going on here. So we're running dockerrun -d. That's how we run things with Docker. Docker compose is sort of the substitute there. And then the ports are mapped into this thing called ports. So they map one-to-one. The end user license environment or agreement, that's the word, goes into our environment variables. Got those mixed up, but there we go. And then we don't have volumes defined yet, but that can come really quickly. And then the image is labeled up here. There's a few other things that get defined here. TTY means it accepts teletype. I forget the actual words, but this is going to make it so you can actually write in and out of the thing. So if you attach to this, it should make it possible for you to actually send commands. Docker attach is not something that I'm intending to cover, but Docker attach is a command that actually allows you to attach to the process running inside of a container. So that's something you want to experiment with. The cool thing with these is if you break them, you saw how I've created like 6 different servers in this so far. So you can just recreate them if you screw it up. Just go for it. And then the other one is a Docker compose thing that does a little bit of orchestration for you. So in this case, we have a restart policy that's going to say, unless it's stopped, restart it. What this means is if it crashes for any reason, maybe there's an out of memory issue or your computer restarts or something else happens, unless it was stopped explicitly by you or somebody else, it's going to restart that image and recreate the container for you. So you might get, it will just recreate it. And that kind of helps if you're trying to, provide a server to people that they can actually use. So the other thing that's happening here is MC. What does that mean? Nothing. That's just a name. You can make that whatever you want. We can call this Minecraft. We can call it Minecraft server, whatever. It's just the name, a unique name for that specific service. Docker compose separates things into services. So in this case, we have our services here, and we just have one, which is just our Minecraft server. You can add other ones. One thing that I like to add to a lot of my servers is Prometheus. So you can actually monitor how many people are logged in, how big is your world, how many resources is it taking, what are events that are happening. You can use that to monitor all of that. And that can just be another service that you tack onto this. And then when you just try to spin this whole thing up, they both come up. And you can even associate dependencies and say this one needs to come up after this one, things like that. So this is the Docker compose. One thing to keep in mind, we just copied this in, but there is a version up here. This version changes the syntax. So that's referencing the version of Docker compose that you're going to need. It's going to impact which versions of Docker compose can run this. It's also going to impact things like what certain syntax looks like. So depending on which one you're looking at, it might change a little bit if you're looking at different examples for different services. So let's host a volume and actually get something to work. So let's do volumes. So if you have the Docker extension for Visual Studio Code, these should be suggested for you automatically. Some of the syntax should just get popped up for you. You should just be able to test it. So you can see here, we're getting a little hint that it's either host path, container path, or volume name, container path. There's also a mode there, but that is optional. That determines the relationship between the host and container sides of that. So you can make it read write or just read or whatever, depending on how you want the container to be able to interact with that volume. If you're reading secrets, for example, you may not want to be able to write secrets into that. Things like that. So let's throw this into /Minecraft data. And we're just going to map that again to our data folder. I think this should be very similar to what we had. Yeah, it's exactly the same. Perfect. So that's going to map it to our volumes. And so now, hopefully, we have an actual persistent world, and we can just spin this up. So the way to do this is with dockercompose up. Up will actually set it all up. Down will spin it all down for you. Or if you just do dockercompose up, you're actually tied to dockercompose when this happens, because we're not disconnecting our terminal. So whichever one you prefer, otherwise just add a -d and it should just work. So dockercompose up will set this up for us. And now the logs are going to change a little bit. Oh, port is already allocated. I am getting too far ahead of myself. All right. Docker PS. And we can just stop that quick. And then we should be able to restart this. And then we can start exploring a little bit more into all of the fun stuff that's actually happening here. There we go. So the first thing you'll notice is the logs are longer. There's extra stuff added here. On the left-hand side, this is color-coded, so you've got multiple services. They will be different colors. But you'll also notice they have a different name. There's a lot coming from this. It includes the root directory name. So Minecraft is my root directory name. And then Minecraft server is the name of the service. And then it's instance 1 of that. You can create multiple instances of it. For this, we do not need that. So that's what's happening here. We're just creating a whole bunch of these as a way to do that. Getting the same logs. They're just marked with what service they're coming from, because theoretically there could be multiple. So that's why you're seeing that. So this should start up shortly. And then I guess were there any flags or anything with this that people thought would be interesting to play with? Also, we're seeing the volume issue I mentioned earlier. But anyway, I'll talk about that in a bit. If there are any like flags or anything in the configuration for this that people think would be interesting to play with, maybe questions they have about how to monitor this, because I think that's sort of where we're leading into is how to do all of that kind of stuff. If there's specific questions there, I can try to answer those in the time we have left. Otherwise, there's a few other things that I can throw in there as a little fun experiments for people to give a shot at. All right. So I said there were some weird volume issues. I can still sign in. Unfortunately, this gets a little bit laggy on this machine. You should not encounter this. All these errors that are flying past in the background. That means something's wrong. So I'm not. I've been trying to figure this out of what's causing this, but I haven't quite tracked it down yet. So that's the thing. It doesn't occur on my other things. I double checked with other places I host these things. Didn't run into any issues, and unfortunately did not have time to set up a quick virtual machine before this. But it should be fine. It triggers mostly when you move. So that's a fun little thing. But this is our new thing. That gives us our server, but also now we have this fun Minecraft data folder. It's this huge folder with everything in it. So this has everything that we just did. This has our world. So this is your world file. If you want to install datapacks, you just drag and drop them into the datapacks thing. Just like any normal, the cool thing with doing it this way is this works very similar to any other server you would do. The only difference is we are using a container as the runtime for it, instead of running it manually on your own computer. So that means you can use all sorts of container orchestration stuff to manage your container and learn a little bit about containers, but you also get access to everything just like you would with a normal Minecraft server. So we can spin it up and spin it back down just by running Docker commands or just doing container stuff. But if we ever want to change things, we just go in here and you have access to it. So that's how that all works. Somebody mentioned, Trogdor mentioned that they use Spigot. So let's wipe all this away and switch over to Spigot. We do actually have to remove this because different things aren't compatible. So pick one. The cool thing with this is it makes it really easy to explore different server things. So if you are exploring and trying to figure out if you want something, this could be a fun way to kind of tinker with different ones without you having to go through all the setup, because this will kind of handhold you through that. It can install them for you automatically and get them all set up. And it just becomes a one-line thing. It's type something. I believe just type spigot. So I could actually try this, but I can also show you why I think it's type spigot. If I go up to, what's the command there? There we go. So there's a whole bunch of different server types for Minecraft. Some of them have different things. I'm not going to go into that because I don't actually know all of them. But we were talking about Spigot, which is good because it leads into bungee cord, which is a really fun use if you want something that's like distributed and a cool use for this entire thing. So what type equals Spigot is what we want. And nothing else has to change here. So we're just using the exact same thing. You can see all of these parameters are the same. The only thing that's changing is that we have a type equal to Spigot. And so what this is going to do now is switch everything over to use a Spigot Minecraft server. So it will download Spigot for us and set that all up. It means if you want to run Bucket or Spigot mods, that all should work. And you can just go from there. You have a Spigot server. Which is also compatible with bungee cord. Bungee cord is another mod that lets you run a proxy server for Minecraft. This allows you to have multiple containers with multiple different worlds and have a bungee cord server or bungee cord proxy that points at different ones. So you can actually send people to different places to do different things. So that can be a really fun thing for that, because then if you want to add another server, you just add a new service. And then bungee cord can pick that up. And then your players can just transfer to your entire new world. If you want a survival and a creative world, this gives you a way to do that because you can just switch between them that way. So lots of fun ways to do this. You can also toggle those kind of settings, like creative things are all environment variables. I'm not going to go into all the ways to configure this image because there's a lot. So we're just going to do that. But you can see we do have a Spigot server 118. I'm using the latest of everything just because it's the easiest. But if you are actually trying to host this somewhere, highly recommend pinning this to something. So that's like a sandbox world made in the world you create. Yes, I'm not entirely sure what that question is. Is that about creative mode or about bungee cord, because they're very different. Creative mode lets you just place blocks, but bungee cord is a proxy. So just like if you're using a proxy for a web service, this is that, but for Minecraft. It's just like, why can't I think of any proxies? Okay, weird. But anyway, it's a proxy to send traffic to different places. So if you want to have different worlds, or maybe host some other world, like you have a mini game world that is just mini games that you created and we're like, we're going to do this, or you imported a world from somewhere else and you want to try that. All of these become different options. And so you can actually tinker with different ones of those. So this just gives you those different options. So that's how it all ends up working. Yeah. I hope that kind of covers it. Bungee cord is its own thing. There's a whole configuration that you'd have to go through to do that. And that's sort of outside of the scope of this, unfortunately. But it's a really fun way to practice. And it shows you like how to orchestrate multiple things, multiple different services inside of Docker Compose. Another important thing, one thing that I like to focus on is trying to get everything so that it configures itself. Like the ultimate goal, what we're trying to do is make it so that we don't need to constantly be like manually tweaking individual settings inside of all of these things. You'll notice this has a lot of environment variables. The reason for that is because you don't want to go into your containers and start tweaking certain settings and saying, actually, this 5 should be a 3, or this person should be an op, and have admin permissions. You don't want to do that every time you need to redeploy this thing, especially if you're deploying like a cloud service to like thousands of different computers. You're doing that and you have to log into every single one and do that. And also they can be recreated at any point in time. You're going to have to constantly have somebody going through and signing into each of these things and updating them. It's a lot easier if you do that through here. So you can do that. Some fun projects with this is to actually extend these. We've looked at Docker Compose, but you don't have to do that. You can, if you want, just quickly, just to show that Spigot did set up, I think. It's being very weird. My volumes are all messed up. But anyway, let's pretend like that did a thing. So you could also start extending this yourself. Like I said, Docker images are just a series of configuration layers. So if we want to create our own Docker file, we can do that. And we can just use from, what's the name of it? This. And you can just base your Docker file off of this image. We'll just pull from the latest version of that. And then you can just start adding onto your Docker file and create your entirely own derivative of this and just keep adding onto it. So if you want to run certain things or tweak other things, a lot of the stuff doesn't need this. This is entirely extra. But if you're looking for that and you're curious about how to do that, this is an option for you. The other fun thing, the thing that gets really interesting, is like dashboards, for example. It can be really useful to actually see like what's actually going on. Why is my server not performing very well? Why is it stuttering? How many people are online at any point in time? Things like that. Is a player farming too many chickens? You can actually monitor that through a lot of this stuff. So you can actually set up telemetry for the number of chickens on your server if you really want to. And that actually gives you like good, useful information about how to set up dashboards and telemetry for cloud services, which I think is just super cool. I think that's a super fun way to learn that. So that's sort of why I wanted to take a look at this. There are like Prometheus plugins, for example, for different Minecraft things. This is the Minecraft Prometheus plugin. Minecraft Prometheus Exporter, is one that I was just recently looking at. That's another project out on GitHub. And this exports from a Spigot server into Prometheus. So you actually have a a Prometheus endpoint that you can just add to your Prometheus server and just start pulling metrics from your server and go from there. And then you can start creating dashboards and doing everything else that you would do with a normal thing. Just now it's Minecraft. And so the cool thing with this, the reason that I like this as a learning tool is, unlike with like a web server where you might run it for a few minutes or something, this can be something that you can leave running for a very long time. And it can introduce use cases and patterns that you might not get exposed to if you're just tinkering with like small web apps that just you're using as a development environment. It can start causing those things, and also other people will start reporting issues because maybe things are laggy on their end or something, and it gives you those hooks to start exploring different parts of why all this cloud stuff is so interesting. So yeah, I think that's interesting. Are there any questions? I think we've run out of time at this point, but there's so much more. We are going to be doing this show every week. So if people have suggestions for things we can do, if they want to see more of this, my plan is eventually to bring this to Azure. That might happen next week, or it might happen in the future. But either way, if there are things people want to see in this show, let me know. But otherwise, I will leave it there. And thanks everyone for joining.
Thank you, Sam. I'm just going to add this slide. If anyone has any feedback, we would love to hear on any topics or how today's show went. Just let us know. The event code is 15379. Until next time, thank you. Bye.
Thanks, everyone.